Good morning. In our previous discussion, we have discussed what are galvanic cells, electrochemical cells, and also discussed few terms: free energy, entropy, etc. Right? Now, let us see how the electrode potential of an electrode depends upon the concentration of the species in which it is dipped in. So this relation is given by equation called as Nernst equation. So Nernst is an German physical chemist who formulated this equation at the age of 21 years. So this electrochemistry, the Nernst equation, it relates reduction potential of an electrochemical reaction. It might be a half cell or a full cell reaction to standard electrode potential, temperature, and all other activities of the chemical species undergoing redox reactions. So what are redox reactions? Redox reactions means reactions where oxidation and reduction occurs simultaneously. We have discussed what is oxidation. Oxidation means loss of electrons. Reduction means gain of electrons. If these two reactions occur simultaneously, then it is termed as redox reaction. Now let us see how Nernst arrived to this equation. So Nernst equation relates or gives relationship between electrode potential of the cell and concentration of the species in which it is dipped in. So Nernst considered the following reversible equation. So Mn plus n electrons gives M. So metal ions will undergo reduction reaction to give M. It will accept electrons. So these products and reactants are in equilibrium with each other. Since products and reactants are equilibrium with each other, there exists a equilibrium constant K. So from thermodynamics, it is very clear that K equals concentration of products by concentration of reactants. From the above equation, K can be given as concentration of M by concentration of Mn plus. So if you write, we have different types of brackets, right? We have small brackets, flower brackets, and big brackets. If you write something, some numbers inside the big brackets, it is termed as concentration. So here K equals concentration of M by concentration of Mn plus. Let us consider this as equation number 1. So from the above equation, so any reaction which occurs in the universe, it will be carried out with some work done, right? So if A plus B gives C plus D, when this also, that some work will be done. So any work will accompany with some decrease in free energy. So the decrease in free energy is given by delta G equals minus NF. That is, decrease in free energy is nothing but some work will be done. So some maximum work is done is given by W max equals minus NFE. So but as per thermodynamics, delta G equals minus NFE and delta G naught equals minus NFE naught. So where delta G is Gibbs free energy and delta G naught is standard Gibbs free energy. N is number of electrons, F is Faraday's constant, E is electrode potential. So from Van 't Hoff's equation, we have delta G equals delta G naught plus RT ln K. So now where R is delta G is Gibbs free energy, delta G naught standard Gibbs free energy, R is gas constant, T is temperature, K is equilibrium constant. So we'll substitute for the values for delta G naught, R and K. When we substitute, we get minus NFE equals minus NFE naught plus RT ln concentration of M by concentration of Mn plus. So we want, what do we want? We want the relationship between the electrode potential E and the concentration which is on the right side, concentration of M by Mn plus. But what we have minus Nf. We're supposed to remove that. So how do we remove? We're going to divide the entire equation by minus Nf. When we divide the entire equation by minus Nf, what do we get? See, we're dividing. When you divide, what will happen? The minus Nf in the numerator will get cancelled with the denominator. It ends up with E equals E naught minus RT by Nf ln M by concentration of M by Mn plus. So we are supposed to convert minus into plus. We want this entire equation to be in positive. How to do? Or instead of having a ln, we want to convert into log. We don't want natural log, we want normal log to the base 10. So how to convert ln to log? In order to convert natural log to log, we're going to multiply it by 2.303. When we multiply it by 2.303, what happens? E equals E naught minus RT by NF log concentration of M by concentration of Mn plus. So 2.303 is the conversion factor. Okay. So now we want to change the entire equation to positive. How to change? We're going to interchange the numerator to denominator. You know that log A by B equals minus log B by A. Right? Log A by B equals minus log B by A. So applying the simple mathematics here, we get E equals E naught plus RT by NF 2.303 log concentration of Mn plus by concentration of M. So we are changing the sign and also we are converting natural log to log in a single step itself. We are converting the natural log into log to the base 10 and we are changing the sign negative to positive in the single step. That results E equals E naught plus RT by NF 2.303 log concentration of Mn plus by M. Now we are going to substitute for R. So temperature 25 degrees Celsius. R equals 8. R is what? R is gas constant. So what is the value of R? 8000. Excuse me. R is a gas constant. Value of R is 8.314 kilojoules per Kelvin. F is Faraday's constant, 96,500 coulombs. So when you substitute for R, F at temperature T is equal to 25 degrees Celsius, the above equation will reduce to E equals E naught plus 0.0591 by N log concentration of Mn plus by concentration of M. So now this is for a double reaction. So I mean it's a full cell, right? For half cell, what is the Nernst equation? So if we have anode, cathode both, then we can substitute cathodic concentration in the numerator and the concentration in the denominator. If you have, for instance, you have only a single cell, half cell, then we are going to take concentration of M equals 1. When concentration of M equals 1, what happens? E equals E naught plus 0.0591 by N log concentration of Mn plus. So this is the required Nernst equation for single electrode. For double electrode at a full cell, we are going to use the previous reaction. For a single electrode, we are going to use this. Thank you. We will discuss problems and other topic in our next session. Thank you.